four of us are talking about this huge topic. As I said, this is a huge topic, needs a lot of unpacking, and that's why it's the four of us. So today we'll be talking about Gen AI meets data mesh.
Sorry, folks.
I think Rahul did introduce data mesh, and a lot of us already know what data mesh is. We have been speaking about it for the past few years, a new paradigm of managing your data at scale. Gen AI definitely needs no introduction. All of us are using Gen AI powered tools. All of our organizations are after becoming a Gen AI driven organization. What is interesting is the intersection of these two. How can data mesh get benefited from Gen AI, and how can Gen AI be the last mile for data mesh? So moving on. Just a quick recap of what data mesh is. When we started building data platforms and we started scaling, we realized that the traditional ways of building central monolithic data platforms would not scale.
No, I'm good.
And that's where data mesh was introduced. Data mesh said that each organization has domains, right? Your organizations would have domains like IT, finance, marketing. These domains have peoples and processes associated. These domains also have systems associated, which are generating data. So why not we extend the same boundaries to data as well? Because the people and systems who are generating this data, they understand the data the most, and they will help us bring out the most value from this data. So we said, domain owners, take your data and then bring it up for the entire organization as a data product, right? So just like I use any other external API, I will use your data as a product. For that to happen, you should apply product methodology to tell me what your data is. Where does the data reside? Am I authorized or not authorized to access this data? And to make that further more possible, because I now have to build data products, I need some infrastructure capabilities, I need storage, I need compute. That was provided by a central team, because this does not need domain knowledge. The central team can build capabilities that the domain team can use. And then finally, all the domain teams talk to each other using some standard, I should say, protocols, which is called as federated computational governance. Summarizing, data mesh was this approach to handle analytical data at scale, and there was not just a technical aspect to it, but a social aspect as well, when we said that now different set of people are responsible for their own data and building all the attributes into their data. Now, that was all about data mesh. How come Gen AI come into this picture? So when I spoke about data mesh, the architectural quantum of data mesh is a data product. How many of us heard the keynote from Vanya and Bharni? Any insights from there about DAXIS? We did hear about it as an upcoming trend, right? Anyone? Yes, yes, yes. Anyone else wants to add? What does DAXIT make you do? What does DAXIT enable your data products to do? Because your data product is following all of these principles, DAXIS, which stands for data products being discoverable. Anyone in the organization, I am from finance department, I can go to my platform and say that give me the marketing data for last month. That is discoverable, addressable. It has built-in trust and security. And because of all this, which is paramount for a Gen AI driven application, my data products can help organization become a Gen AI ready organization. Right? We heard it in tech trends, now we'll show it in practice on how we did it on multiple projects. And in turn, my Gen AI can help me scale data products. We'll see how. Now, this is all good. This is all looking good in theory on papers, but especially with data mesh, what we observed was organization could not get complete benefit of data mesh. The reason was they thought all those four principles that I talked about, I will do all or I can do nothing. And because of that, they saw failure in their efforts in implementing data mesh. And we saw it too with our clients. And then we started doing was looking at all of these principles independently and in exclusivity. Although these principles complement each other, but you don't have to pick all of them. You can pick and choose each one of these based on your organization's data maturity. If I'm a startup, I might not have different departments. There is one person who is doing finance, marketing, HR, everything. So how do I create domain-oriented boundaries, right? And that's where I cannot pick that principle. But can I still do self-serve infrastructure? I can, because nobody is stopping me from building capabilities for storage and compute. If I'm a mature organization, I have all the SOPs set up, I have people and processes set up, then definitely go ahead, implement domain-oriented ownership and implement federated governance, right? So keeping these two thoughts in mind, that I can deconstruct data mesh, and then the architectural quantum of data mesh, which is data product, helps me move towards GenAI. We implemented it in 2 case studies and we will talk about them. So this is our first case study, a very hierarchical organization, top down, there was centralized control. This was an innovation first leading consumer electronics brand, very popular with ladies. I'm sure most of you have got the name. And the challenge was, as I said, because this was a hierarchical organization, how do I implement domain-oriented boundaries in federated governments? If the central authority is not letting go of the authorities that they have to the different domains, then it is very difficult to implement that kind of domain boundary, right? And because of this, we started working with them closer to understand, even if you want to do data mesh, what is it that you can pick up from data mesh? And for this organization, for the existing hierarchy and an existing mature data platform, we started standardizing some of the capabilities around storage, compute, quality, security. And when you standardize all this, what do you get? You get data products, right? People were able to build their own data products. So the outcome was we were still able to move ahead in the direction of data mesh, but we did not disrupt the organization. So we reached a successful recipe of embracing the existing people process of the organization. A double click into the same case study. What did we actually do? Like all I said sounds good. What did we actually solve? What was the business benefit and what was the dollar figure that they got from it? So this was for research and design department of the same organization. As I said, they are innovation driven, right? So they'll keep coming up with new products, new consumer electronics, and their consumer electronics are considered as a niche electronics in industry. So their bread and butter and their trade secret is their design, right? How are they building their products? And that data, called as bill of material data, BOM data, was living in some systems, of course. But for this bill of material data, there was some additional data, ancillary data as well, right? What is the cost of each part that I use in building this equipment? How are these parts assembled into sub-assemblies? From which supplier should I get them? What is the SCM looking for each part, right? What is the quality of these parts? And the research and development department wanted to look at all of this data so that they can build new products, right? If I have an existing product and some parts and some sub-assemblies can be used in building new products, or in fact the existing products can be optimized, why not do that? However, the challenge was, as I said, the data was not shared. In the keynote also we heard that if you don't have proper data product setup, you have data silos, you cannot build a holistic picture of the organization because you're just looking at dots. You're not connecting those dots to become a whole picture. With our idea of implementing data mesh and not disrupting the organization, this is what we built. So if you look at this diagram, from left to right, right is where my research and design department was sitting. And this is where they needed all of that bill of material data, which is very hierarchical, a tree-like structure, right? Where you say that there is a part and then it has sub-parts and assemblies and so on and so forth. It is a very tree-like structure or a graph-like structure. They needed this information. And without disrupting the entire data pipeline, so we did not touch any of the data sources, because they were coming from different departments. We did not touch any of the existing data pipelines which are transforming the data, because that was also centrally controlled and we could not just change it for one department. What we did was, for the final layer, which is the consumption layer, we built their very first data product. And it was the data product that brought together all of the different data points sitting there and built in quality and security. As I said, this data was a trade secret for them, and they could not expose this data to each and everyone, even within their organization. So with a graph-like structure, we associated nodes to specific users who have the visibility of that structure and the structure below. And we built in all the DATSIS principles that I talked about into this data product. Looks good, right? Sounds good. Everyone can build data products. But everything has a flip side. There is always a but. The but here was, it took us a lot of time to build this first data product. And even if they appreciated the results and the business impact that we created with this data product, the question was, how do we scale from here? We are such a big organization, and if we continue on the same path, we might not be seeing the results for coming few years. So how do we accelerate building data products? And that's where Antony will walk you through it, and also our second case study.
So as you have actually built a first data product organization, you want to move to many data products. So the first step that an organization needs to do is see the sequence of steps that needs to be taken to create a data product. So the first step is like raw data ingestion, where you bring in raw data from multiple different parts of your organization. The next step is where you curate the data attributes. I have this column, what do I call it? What do I call the data product? What is this data product is going to be used? All this happens at this particular step. And finally, you make the data product available for consumption across the organization. The data attribute curation part is a very critical step, as this is where the DATSIS principles are followed. You make the data product self-describing, and you ensure the trustability by coming up with the data quality rules. But this is also the step which is the most time-consuming one. Generally, SMEs who support these initiatives have limited time to cater to this because they have other critical deliverables to work on. And even when they work on this, they might need to have some kind of prior knowledge about the different data products that the organization already has and the current industry standards on what the naming and data quality rules to be. And finally, even with the same data set, they'll need to understand what it tries to solve so that all the names and the descriptions can be understandable by anyone who wants to consume it. So we thought for a moment, AI has started to revolutionize different process. It's trying to accelerate a lot of things. So can we do the same? And every question that we ask during the data product design process, can we let AI try to answer that? So some of the challenges that we generally have here are naming the column. The column name should not be too long. The column name shouldn't be too short because someone can't understand it. It needs to be consistent across what and all names you have done in the past. So can AI help us by means of giving some examples and the current industry standards? This is the name that you can use for this particular column. Once you have the column, is that enough to describe it? You might need a description. For the description, you can still leverage AI to tell it, see, this is the context that I want to solve with this. So can you give me a description which will help anyone in the organization better understand it? And finally, trust is very crucial for a data product. And trust is only achieved by adhering to the data quality rules. And AI can even help in this regard, where by telling the business context and what organization standards and the data profile that you have, give me the data quality rules to apply to this. So this is all well and good. So we thought the current process of a data product creation is a reinvention step. Everywhere you need to think, come upon what you want. Can this become a review exercise? Can an SME just see, this is what I want to edit? And we are using AI, but is that alone enough? Can we also bring in the past decisions that you have made in creating existing data products? And all this we have come up together to put together as a solution for one of our pharma client. And let me welcome Pallavi to talk more on that.
Yeah, So here's the solution, the AI-powered data product design recommender that helps transform raw data set into well-defined standardized data products by accelerating the creation of data product specification. So now let's unpack the high-level architecture of this solution. Let's go step by step. So this recommender has two parts, large language model part and the knowledge base. And we start from the raw data set. We get the data and the schema. And it passes through the first step of matching, where we try to identify if any of the columns in the raw data set matches with the previously standardized column in the knowledge base of data products. And if we identify them, then the associated attributes are recommended, which are standardized column name, semantic description, data type, and the relevant data quality rules. And if we are not able to identify with the past data products, then it moves towards the AI-driven path, where LLM is leveraged to generate the recommendations. Now what next? So the schema enrichment part comes, where the knowledge base is leveraged to recommend additional interoperable columns to be added into the data product. So this system does not only look at what's in your data set, but it also tries to make it more usable across other data products in the wider data ecosystem. And using all these outputs, all of things is combined into the data product spec, which you can very well leverage into the organization's data product onboarding pipeline, which creates the data products. And once your data product is in production, then the attributes are fed back to the knowledge base, thus making it smarter and smarter after every cycle. So if we try to observe this high-level architecture, we will see, like in the early phases of the data product ecosystem, when you have little or no data products in a knowledge base, then AI can play a pivotal role, not just by accelerating the initial curation, but also enriching your knowledge base. So over time, a point can come where your knowledge base itself becomes mature enough to recommend high-quality recommendations. Now, let's zoom into the knowledge-based driven recommendation, which we talked about. So once you have some existing data products in your knowledge base, this powerful mechanism kicks in. So from the raw data set, we get the column name, data sample, and the data profile. And it goes to matching, which we already discussed. So one example of the matching can be a data pattern match, where you try to pass the column values against the predefined regex pattern, and if it passes a particular threshold, then the associated attributes are recommended. Or it can be, we talk about AI, right? So it can be an advanced system such as RAG, where your knowledge base is a vector database, and some similarity algorithm is run to retrieve the most relevant standardized column vector to use them to recommend these attributes. Then in the schema enrichment step, we leverage knowledge base to use the historical mappings, the ontology, and the lessons learned from the previous data products to recommend the additional columns. Now let's zoom into the AI-driven part. So the same set of inputs are sent to the AI engine, which is powered by LLM. And this AI engine can be like a single agent or part of a multi-agentic system depending on the implementation. But what makes it truly efficient is the data product context and the compliance and quality standard which you add it into the AI engine. And leveraging all these inputs, it recommends the attributes. So far, so good. We have seen how this works out. Now let's see how it plays out in practice.
So an SME who wants to create a data product first will need to bring in the raw data set that they want.
Sorry.
So as they bring in the raw data set, they'll provide this as input to a data product design recommender. And the design recommender, by means of the knowledge base, the organization and quality standards, and the large language model, is going to come up with recommendations for the column name, description, and data quality rules. And the SME will now review these and approve the ones that they prefer and ensure that it satisfies to their use case. And once they begin onboarding of the data product, and the data product becomes available for consumption across the organization, all the decisions that they made for this particular data product goes back into the knowledge base. This ensures that there's a continuous evolution of the knowledge base, getting the LLM insights, the SME recommendations, and the existing past decisions made based on knowledge base. But is this enough? There needs to be a governance team who continuously ensures that the organization and quality standards are continuously updated for the system to perform efficiently. So let us see how we did this for our pharma client. So our pharma client was one of a leading life science organization who wanted to harmonize research data in order to drive faster drug discovery. They were an organization where there were different factions within the organization, and each had their own data platform. They were maintaining it in different data formats, PDF, Excel files, their lab notebooks. And all this different data they were maintaining using their own standards. So Thoughtworks partnered with them to build a data mesh platform, and we leveraged standardized, shareable data products to empower the researchers, the clinicians, and the data scientists to be able to validate their hypothesis, identify the drug candidates, and do drug discovery faster by being backed by data. So the data set that you see here has few columns. If you take a look at the CP input column, we know it is a chemical equation with carbon and oxygen. But what standard it is following? How do we know this is what it is representing? Because there are many ways of representing chemical equations. Similarly, there is an RO3 column. It's a Boolean value. Is it a status? Is it a flag? Or does it represent something else? Someone in the organization might not understand what it is. So when you give this raw data to our recommender, you get the following output. All the raw column names get a standardized column name. The CP input is represented as the SMILES value. So SMILES is an industry standard for representing chemical equations. The HBA and HBD are known as the H-bond acceptors and H-bond donors. And you get the column description to tell someone who looks at this data, this is what it represents. And finally, the RO3 is known as the rule of 3, which is one way of screening for fragments in the drug discovery. Then you get the data type recommendations and the data quality rules recommendation. And finally, you have another important recommendation, which is the interoperable column. By means of the SMILES value, you can actually connect to another data product compound structure by the INCHI key column. By combining different data products, a SME or a researcher will be able to get a unified view across the data and be able to make decisions at a better rate. So what are the real gains of the system? By accelerating the process in which the data products are created, we are bringing in operational efficiency. And this ensures that the data product becomes consistent and is accurate in nature. And by means of continuously evolutionizing the knowledge base, we make sure that this is a scalable process. As at the starting stage, LLM is what you will you'll use to kind of give the recommendations, but you'll reach a point wherein the knowledge base will become capable enough to be able to drive data product design. And data quality rules helps to make sure the data quality of the data product is maintained. But these are not without its challenges. Organizations might be stuck to their own data process. So you need to make sure this integrates seamlessly into their workflow so that there will be enough adoption. The next one is there's a general stigma with AI-generated recommendations. So any SME who is doing the data product design needs to validate the description that comes out of this to ensure people can trust the solution. And finally, AI we might think it's all-knowing, but there's a possibility it might not understand what happens in your organization or the nitty-gritties of the business. So you need to provide it the relevant context so that it will be able to bridge this gap.
So the impact we made was transformational on this organization. We were able to deliver 70 plus data products across 6 domains, and the lead time required to create the data product right from the start of the creation to moving it into production was reduced from weeks to days. And teams now use trusted rules and definitions for the data products, making them smarter, faster, and cleaner. SMEs now spend 75% less time on preparation. Why? Because system remembers, learns, and recommends. And it has eventually accelerated the harmonization of the data products due to the semantic consistency and the addition of interoperable columns, which we discussed. So what next? We have already seen the AI-powered data product design recommender, how it accelerates the creation of source-aligned data products. And we no longer start from a blank slate. We have AI to bootstrap the creation of the attributes. But if we try to look the data product landscape through the lens of data mesh, the possibilities even widen. And we can use AI to create the aggregated data products as well, which is nothing but combination of 2 or more source-aligned data products. So we can build an accelerator to discover the connection between the data products. And AI can play even a more strategic role when we move towards the consumer-aligned data products, which are created for solving a particular business use case. Let me give one example. So, if a science team needs a dashboard for comparing the performance of a drug across various models, and so how AI can help here? So, AI can step in, select the relevant data products, stitch together them, and provide a tailored view for solving that particular team's needs. So far, we have seen these all accelerators, but there are countless opportunities and possibilities where AI can help to implement the data products and moreover the data mesh. So let's flip the lens and try to see like what else we have on our plate, and I would like to call Sreerupa for that.
So, talking about flipping the lens. So far, we understood how GenAI can accelerate your data product development by many folds, thus by bringing businesses closer to fit-for-purpose data. Data products, foundationally, are also important for you to leverage generative AI effectively. When done right, these pave a way for a natural progression towards a data-first organization. Now, let's understand with a simple example what do I really mean. So a data product, in its most simple form, could take shape of a report. A report that is answering very basic questions, like, what does my production output from last quarter look like? How much downtime did I see on my production lines? So what I'm trying to answer here is what happened. I'm descriptive. Throw a bunch of transformations, and you could be answering the why. Go diagnostic. You could be answering why did a particular production line have more downtime as compared to the others. Get an ML model into this mix, and you could be talking to future. You could be answering questions like, will I have any machine failure in the next 3 quarters? Take it a notch higher, add AI to this mix, and you could go prescriptive. You could literally say, what is the best possible time to put a production line into maintenance so that I don't impact my forecasted figures? Well, at this point in time, you might wonder, this looks great as theory, but does that mean I have to make quite a few data products to get there? Well, the interesting answer is no. Data products, by definition, are outcome-oriented, which means we keep the business outcomes at the center of our concept. Let's try to unpack this with an example we talked about earlier. Let's revisit our manufacturing example. Here, we simply translated the bill of material into a graph-based model. At this stage, it was answering very simple questions. Something like, what is the total cost breakdown of my bill of material? I'm asking descriptive questions. We added a few data nodes and a transformation, and we could ask questions like, which are the components in my bill of material that are causing my manufacturing cost to rise? I went diagnostic. And this is the point we were able to onboard a lot of analysts from this organization. And as I said, data products are outcome-oriented, and security is sort of in its DNA. These users were added as nodes to this graph, which meant if, as a user, I did not have access to certain parts of this graph model, I would not be able to navigate it. So I was already thinking security from day one. We went further. We added a predictive model to the mix. And we were answering questions like, which components in the BOM could lead to a price inflation tomorrow? And as we speak, the team in charge is already planning to train an LLM model on top of a knowledge graph that is derived from this graph model to answer prescriptive questions like which parts should I substitute? For which parts do I look for alternates to tone down my production cost or probably increase my price point by, say, 5x. And the deal doesn't get over here. With agentic AI, tomorrow they could have specific agents trained to work on very specific cost optimization goals. Whew, that's a lot, isn't it? And at this point, you might feel that it might take me forever to reap gains. I've invested a lot. When do I really start seeing my business benefits? The answer is, if you design this right, you start seeing business benefits from day one, your first increment of the data product. What does that mean? So in its very first shape, we were able to give them 6 times faster queries, which meant they were getting closer to insights or multi-layered questions 8 times faster, which meant they had more time on the table. So they were unlocking more cost optimization initiatives, which also meant they had the potential to unlock more savings on the table. But all of this came because we kept the users at the center of the stage. If you recollect the constraints, these analysts did not want a new tech stack. So we wrapped this data product with a lean UI. So these analysts were talking to a very lean UI instead of talking to GraphSQL, which is again a tech stack would have taken them a learning curve. In summary, what we are trying to say here is we looked at 2 case studies. One was from pharma. We were doing drug discovery. The other was a manufacturing problem trying to optimize cost. But there was somewhat this innate synergy between GenAI as well as data products. While GenAI helped us standardize the column names, enforce quality rules, automate repeatable transformations, data products provided fit-for-purpose data that helped in model selection. Now, because quality is already enforced in this data, this data is reflective of the real world, so model tuning gets easier. Security is ingrained, so you are already encouraging responsible use of AI. So this synergy, while we demonstrated through 2 case studies, one was pharma, the other was manufacturing, we can replicate it in almost any industry if we take care of certain points. What are those? So when you look at mesh as your way forward, don't take it as an atomic concept. Pick the facet of mesh that is closest to your needs. When you're looking at data products, automate the obvious, which means in your entire life cycle, you might have multiple tasks. The repeatable pieces are your lowest hanging fruits for GenAI automation. Because you are thinking data products, think outcomes, users from day one. For it is only these data products that will scale to give you AI readiness. And lastly, GenAI is a technology. Data product is an architectural quantum. Magic happens when you don't forget the human in the loop. The humans of the organization hold the guiding context. They are the ones who can co-create the solution for you, spot failures in the concept, not in execution, and thus they can help you with responsible use and effective governance. I hope you liked listening to us. We are now open for questions or thoughts. Additionally, there's going to be a QR code that we request you to scan. Give us your candid feedback, help us improve. Thank you.